question is, two particles are projected from a same point at the same instant with velocities whose horizontal and vertical components are u1, v1 and u2, v2 respectively. Prove that the interval between their passing through another common point of their path is given by twice of v1 multiplied by u2 minus v2 multiplied by u1 divided by g times u1 plus u2. In this case, let us first of all draw a diagram. So two bodies are given. Let us suppose this is body A and this is body B and this is body B, and they meet at another point C. So x will be given by this and y will be this much. It means the horizontal distance traveled by both A and B will be x, as well as vertical distance traveled by both A and B is given by y. And let us suppose that they meet after the time taken by A to reach point C is given as T1, and for the particle B to reach point C is given as T2. So we can write for A, U1 is the horizontal component, V1 is the vertical component, and T1 is the time taken. And so we can write that x1, suppose for A the distance is given by x1, then it will be equal to u1 multiplied by t1, let this be equation number 1, and the vertical distance is given by y1, which is equal to v1 multiplied by t1 minus 1/2 g t1 square. This will be equation number 2. For particle B, we are given as u2 is the horizontal component, v2 is the vertical component, and time, let's suppose we are given as t2. So we can write x2 similarly u2 into t2, and y2 is equal to v2 multiplied by t2 minus 1/2 g t2 square. So let this be equation number 3 and equation number 4. So from equation number 1 and equation number 3, as the horizontal distance traveled by both A and B is same, so we can write that x1 is equal to x2. So we get u1 t1 is equal to u2 t2. From this we can find that t2 is equal to u1 by u2 times t1. And also the vertical distance traveled by both are same, so from equation number 2 and equation number 4, y1 is equal to y2, we get v1 t1 minus 1/2 g t1 square is equal to v2 t2 minus 1/2 g t2 square. This can be further solved as we get v1 t1 we get this as v1 T1 minus 1/2 G T1 square is equal to, we substitute the value of T2, V2, T2 is given as U1 U2 times T1 minus 1/2 G U1 U2 T1 whole square. We can write this as V2 U1 U2 T1 minus 1/2 G U1 square U2 square T1 square. So this will be equal to U1 T1 minus 1/2 G T1 square. So we are going to combine like terms. We will be taking U1 to left side and the other component to the right side. So we get this as V1 T1 minus V2 U1 U2 T1 is equal to 1/2 G T1 square minus 1/2 G U1 square U2 square T1 square. Taking T1 common from the first part, we get V1 minus V2 U1 times U2 is equal to, and taking common from the right side T1 square, we get 1 minus U1 square divided by U2 square. So T1 cancels out by this square, so taking now LCM, we get V1 U2 minus U2 V1 divided by U2 is equal to 1/2 G. We get U2 square minus U1 square divided by U2 square times T1. This cancels out by the square part, so we get T1 is equal to 2 by G V1 U2 minus VT U1 divided by U2 square minus U1 square times U2. So we already know our T2, which is given as T2 is equal to U1 minus U2 times T1. So we are going to find out the difference. So we write T1 minus T2 is equal to T1 minus U1 by U2 into T1. T1 is given by 2 by G V1 U2 minus U2 U1 divided by U1 square minus U1 square times U2 minus U1 U2 and multiply by T1 which is equal to let me do it another way. We can take T1 as common, it is much more easier. So we get 1 minus U1 U2. So we can write this as T1 minus T2 is equal to T1 U2 minus U1 divided by U2. Now substitute the value of T1, we get 2G V1 U2 minus U2 V1 divided by U2 square minus U1 square, and here we have times U2 multiply by U2 minus U1 divided by U2. U2 cancels out by U2. We can write the denominator as 2 by G V1 U2 minus U2 V1 divided by U2 minus U1 U2 plus U1 multiply by U2 minus U1. This cancels out. So the difference in the time, if it is represented by delta t, so we can write delta t is equal to 2 by G V1 U2 minus V2 U1 divided by U1 plus U2. This is the final answer that we have to prove. Thank you.